morning students. Chapter 7, System of Particles and Rotational Motion. Yes, you know what is translational motion, means linear motion, and rotational motion. Now in today's lecture we will see what is rolling motion. So first of all we will see one difference between translational motion, rotational motion and rolling motion with the help of one example disk. Okay, for example, it is level surface. Okay, on this level surface it is one disk. This disk is moving such that each and every particle, it is its center of mass, each and every particle have linear velocity in this direction, okay, and yes, as it is rigid body, linear velocity of each and every particle will be same, and it is same as velocity of center of mass, So if velocity of each and every particle is in same direction, parallel to level surface, then it is called pure translational motion. It is called pure translational motion. Clear about this? When this velocity of each and every particle is same and is equal to velocity of center of mass, and they are moving parallel. Okay. Next is if it is disk and about this axis, it is performing motion like this. And clockwise direction or in anti-clockwise direction. For example, it is performing rotational motion in anti-clockwise direction. Okay. For example, it is performing motion in anti-clockwise direction. Okay. Like this. It is rotating like this. Clear? Then it is called pure rotational motion. Yes, in pure rotational motion, what happens? See, if I am taking any particle, for example, it is one particle, then for this particle, what is direction of linear velocity? We know that this particle will perform circular motion and its velocity is in direction of tangent. So it is its V. Clear about this? Okay, and how to write equation of this VL? This VL we can write as it is omega into R, where it is R, that is radius, and omega is angular velocity. Clear? So in this case, how to find direction of this linear velocity on account of rotation? It is in direction of tangent on its circular path. Okay. So yes, difference between pure translational motion, pure rotational motion. Now we will see what is rolling motion. Rolling motion is combined effect of translational motion and rotational motion. Okay. Here I will write one statement. Okay. Rolling motion is combination of translational motion and rotational motion So yes, this one point you have to remember. Okay, if these two motion combine, then it forms rotational motion. What is an example of rotational motion actually? Okay, if I have one wheel and that wheel is rotating here only, here only, here only, here only, then it is rotational motion. But motion of wheel of any automobile, okay, for example car or two-wheeler, then see that wheel is rotating and as well as it is moving, and as well as it is moving on road, on level surface. Yes or no? Yes, it is. So that wheel is rotating as well as it is moving in forward direction or backward direction. Yes, it is moving. Then such motion is called rolling motion. Such motion is called rolling motion. Okay, if you drop any ball on ground like this, okay, then motion of that ball is, yes, it is rolling motion. Yes, it is rolling motion. Clear? Okay, so what is rolling motion? What is rolling motion? So for example, see, it is level. Okay, the same disk is here. For example, here it is this. For example, here it is this. Okay, it is its center of mass. It is its center of mass. If this disk is moving in forward direction and rotating in this direction, okay, then combination of these two motion is called rolling motion. Okay, if this wheel is moving, is rotating in this direction and it is moving forward and is moving forward and is moving forward, then such motion is called rolling motion. Clear about this? Now in case of rolling motion, what happens? Each and every particle is under the effect of two types of velocity. One velocity due to translational motion and one velocity on account of rotation. And one velocity on account of rotation. For example, if I am taking one particle here, that is P0. That is P0. Okay, so due to this P0, due to this rolling motion, for point P0, you will have two types of linear velocity. First, due to pure translational motion, and due to that translational motion, yes, velocity of each and every particle will be same and is equal to velocity of center of mass. So that velocity, it is like this, it is V center of mass. Any doubt? This velocity is on account of translational motion. This velocity is on account of translational velocity. Clear? Motion. Now, see, it is in circle. It is a circle. It is performing circular motion on this. Okay? So, on account of rotation, what is its linear velocity? Here, it is in direction of tangent. Here, it is in direction of tangent. It is VL. It is VL. Any doubt? Any doubt? Sure. Okay, so this V center of mass is velocity on account of translational motion, and VL is equal to omega r. Is VL is equal to omega r is on account of rotation. Is on account of rotation. Clear about this? And therefore its resultant velocity, that is VPO, it will be in this direction. It will be in this direction. VPO. Any doubt? Any doubt? Okay, so yes, this VPO, it is resultant velocity. VPO, it is resultant velocity. Clear about this? So in case of rolling motion, what happens? So yes, each and every particle will have velocity two types. One due to translational motion and another due to rolling rotational motion. Now, if I am taking this point, for example, this point. Okay, so at this point what happens? So yes, at this point, due to translational motion, the velocity, it is in this direction. That is V center of mass. That is V center of mass. Okay, and as it is performing rotational motion in this direction, at this point, at this point, what is direction of tangent? Direction of tangent, it will be in this direction. So VL will be in this direction. Yes or no? And yes, and let it is point P1. Let it is point P1. So at point P1, yes, it is velocity due to translational motion. It is velocity due to on account of rotational motion. Now, what is condition for rolling without slipping? Rolling without slipping. Condition for rolling without slipping is, as these two velocities are in opposite direction, their magnitude must be same. Their magnitude must be same. Okay, so their magnitude must be same. Direction opposite, so resultant velocity of this point P1 will be 0. Resultant velocity will be 0. For very small time it will come to rest, and due to that it will perform rolling motion without slipping. Otherwise it will sleep. Otherwise it will sleep. Clear? So yes, at point P1, V center of mass and VL are in opposite direction. They are in opposite direction. They are in opposite direction. Okay. So therefore, condition for rolling motion without slipping is V center of mass is equal to VL. That is, V center of mass is equal to omega r. If radius of this is r and angular velocity is omega, then yes, you can write V center of mass is equal to it is omega r. Yes, V center of mass is equal to it is omega r. Clear about this? Okay, so due to that velocity of point P1 becomes 0 for very small time, it comes to rest. Okay, and due to that, rolling without slipping is possible, and rolling without slipping is possible. Otherwise, okay, if this condition is not satisfied, then this disc will sleep over this surface. It will sleep over this surface. See, there is difference between sleeping and rolling. Okay, sleep means this disc is dragged like this. Okay, and rolling motion means it is performing rotational motion and it is moving on this level surface. Okay, so there is difference between sleeping and rolling. So yes, at this point P1 you have to remember that these two velocities, they are in opposite direction, and what is condition. For example, another point at point P2. At point P2 what happens? See, at point P. So at point P2, see, yes, due to translational motion, V center of mass is in this direction. Object is performing rolling motion in this direction. So due to that, VL, it is also in this direction. So at point P2, they are in same direction. At point P2, V center of mass and VL are in same direction. They are in same direction. At point P2, V center of mass and VL are in same direction. So therefore, velocity at point P2, that is Vp2, is equal to V center of mass plus VL is equal to, right, V center of mass plus, see here, Vl is equal to V center of mass. So you see I can write V center of mass. So it is 2V center of mass. Clear about this? Clear about this? Because see, this point P1 is also on surface, P2 is also on surface. That's why I can write this. Vl is equal to it is V center of mass. Clear about this? Clear about this? So yes, you have to remember this topic, this figure. Okay, what happens in rolling motion for each and every particle. Clear about this? Yes, again, see or understand this topic carefully. What is pure translational motion? What is pure rotational motion? And what is rolling motion? Rolling motion is combination of translational motion and rotational motion. Okay, see, it is rolling motion on level surface. Yes, on level surface. It is rolling motion on level surface. Now we will see in the next topic rolling motion on inclined plane. Rolling motion on inclined plane. Clear about this topic? So yes, it is again one important topic in rotational motion. Okay, and also for GWND part that you have to remember. Clear? Okay.